Okay, so the most important pieces for you to know about the input-output section are these equations. That y equals ax, that's how you find that internal consumption or output matrix. To find the surplus, you do x minus y. And to find that gross production matrix, if you already know the external demand, that you do I minus A inverse times D. So those are your three important equations that you're responsible for knowing. Let's do one more example where we use all of these again. Where this time we're considering a highly simplified economy with three producing sectors: agriculture, manufacturing, and energy. And we're given all of the information about how much we need to produce. So again, these are like producing. So we're making first agriculture, then manufacturing, then energy. So if I'm going to draw then my input-output matrix A. So again, remember, we're using this to make this when we set these up. And we always keep everything in the order that's either told to us or that it's given. So for us, it's going to be agriculture, manufacturing, and energy in order each time. So when we're producing agriculture, that's the column agriculture. That's what we're making. So we need 1 unit of agriculture to make agriculture. Oh, sorry, to produce 1 unit, sorry, we need, how much do we need? We need 0.2 units of agriculture, 0.4 units of manufacturing, and 0.3 units of energy. To make 1 unit of manufacturing, we need 0.1 unit of agriculture, 0.2 units of manufacturing, and 0.5 units of energy. And in order to produce 1 unit of energy, we need 0.3 units of agriculture, 0.1 units of manufacturing, and 0.5 units of energy. So there's our A matrix, and we'll need that later. If we want to draw a diagram to show the flow of goods, and I want to try to keep all that on the same page, so I'm going to squeeze this in here a little bit. We're going to need sectors A, M, and E. And remember, whenever the arrow is going to that sector, that's when we use that variable. So for the first one, we have A going to itself, 0.2A. And what else is going into the A? Well, we have the 0.4 coming from the M's, but that's going toward A, so it gets an A. And we also have what's coming from the energy, and that's a 0.3, but since it's going to A, we use an A. So that's all the A's. That's the A column. Okay, now if we're making manufacturing, we have 0.1 coming from the A. We have 0.2 M coming from itself, and we have 0.5 M coming from the E. Okay, now finally we just have to have all the arrows going into the E. So the one coming from the A is a 0.3 going to the E. And then we have a 0.1 going to the E. And we have a 0.5 E to itself. So that would be the flow diagram. Next, we're asked, suppose the gross production, so we have to be able to know that that means the X matrix, is 800 units of agriculture, 900 units of manufactured goods, and 1,500 units of energy. Find that Y matrix. So we know that Y equals A times X. We created our A matrix. So I'm going to recopy that down. Column wise, it's 0.2, 0.4, 0.3, 0.1, 0.2, 0.5, and 0.3, 0.1, 0.5. And X, we're getting From this information, X being 800, 900, and 1500. So you can grab your calculator. If you so choose, put in your A, put in your X, and multiply them. Or this one's not, this part at least is not too bad to do by hand. If you want to do it by hand, multiply across and down, across and down, across and down. And when you do that, you should get that Y matrix comes out to 700, 650, and 1440. Again, to remind ourselves, so what's being used up or what's the output of each one of these sectors just to keep themselves going of agriculture, manufacturing, and energy. Now, if we want to find the surplus, what's left over then? For that's X minus the Y. So the gross production of all of these minus what's already being used out of each sector. So you have to do it in this order because you have to find the Y to subtract first. So what's remaining? Well, what's remaining is 100 units of agriculture, 250 units of manufacturing, and 60 units of energy. So that's the surplus. So those two you can do in order like that, given the X. Now, if you want to find an X, you have to be given a different bit of information. So in this case, we want to find X if we're given a demand of 100, 200, and 150 agriculture, manufacturing, and energy, respectively. Okay, so we want to find that X. We know that we use the equation X equals I minus A inverse times D. Okay, so this is where you will want to grab out your calculator to do these different steps. Most likely, I would put in the I matrix if you don't have it in there. Put in your A matrix, which is up here. And then give me some notes, right? You can give me some notes. So you can tell me things like, well, when I did on my calculator, when I did I minus A, I got 0.8, negative 0.1, negative 0.3, negative 0.4, 0.8, negative 0.1, negative 0.3, negative 0.5, and 0.5. Then you probably want to tell me what did you get when you did I minus A inverse. Write that down. It's going to be long. You're going to have to round it off, but you can give me those different entries as a place for me to check your work. And finally, what you want to do is you want to take that matrix that you get there and you want to multiply it by D. And it's easier to do if you have it in your calculator. So take this matrix, whatever you have here, multiply that by D, and give me your final solution for X. I'm going to let you do that part on your own, but I'm going to tell you what the answer should be so that you can check it. It should come out as 900, 920, and 1760. Again, so that is what they need to produce gross of agriculture, manufacturing, and energy in order to meet that outside demand and also keep itself running.